Hey everybody, I'm meteorologist Gavin Sandell. Well, when cold air plunges in from Canada, you might have heard that this has been caused by a polar vortex, but that's actually not correct because polar vortices, they exist in what's called the stratosphere, which is the second layer of atmosphere above our heads. We exist in what's called the troposphere, which is the layer closest to us, and that comes from the polar jet stream, which is the thing that brings all that cold air towards us. So it's not the polar vortex. The intricacies between the vortex and the jet stream can influence one another to bring these crazy cold events there, and it happens all from something called sudden stratospheric warmings, which I'll talk about in just a bit. But let's talk first about the polar vortices, and this is a big dome of cold air that's very strong in the winter because the sunlight doesn't shine on it, because that sunlight bends a little bit south, but it's strong in the winter. Those temperatures can be up to -90 or -100 degrees Fahrenheit. Very, very cold. And when those things are strong, the jet stream below, the polar jet stream, it's in what's called a zonal pattern. It goes roughly from west to east, and there's not too many kinks in the jet stream, which means the weather is rather uniform in these times. But when you have these polar vortices that are weaker, it's caught up by this thing called a sudden stratospheric warming. And so let's paint the picture for you. The temperature of the vortex usually follows a cyclic pattern like that. Gets up to -50 in June, maybe -90 to 100 in December. But look at that little spike towards December. Sometimes it'll suddenly just spike up there. It'll maybe 10 to 20 degrees Celsius, even 20 to 30 to 40 degrees Fahrenheit in just a couple of days. When this happens, it completely weakens the vortex and it throws its whole shebang off. And this is actually what's forecast to happen over the next couple of days. Look at this temperature moving down as it typically does during the season, but that green spike is what it's forecasted to be, and actually potentially the warmest at this time of year that it could be on record since the 1950s, which is pretty crazy. So when this actually happens, the jet stream gets very weak, and what happens is then it then kinks down, and it also kinks up, so it can bring warm air from the south in places well north, but it could also bring very cold air down south, which is very common in the months of December, January, and February, and where we see some of our coldest air in moments like that. And so we aren't at quite that place yet where we can determine temperatures or stuff like that. But a look at the jet stream can really tell you a couple of things, especially about what the trends could look like. So look at the timestamp here. This is around Thanksgiving. There's a little bit of waviness here, but it's generally zonal. Over the next couple of days, once we get closer to December, look at how this jet stream just kinks up. Very warm air coming in from the south, very cold air coming in from the north. So this is something that we're going to have to watch, not because of the polar vortex for bringing the chill to our area, but the stratospheric warming events for getting the jet stream wavy and active and propelling that cold air all the way down from the Arctic. For Weather 101, I'm Gavin Sandell.